So welcome everyone. Sorry about my camera angst here. It's probably, like Neal said, it's probably going to require a reboot, and I'm not going to waste any more time with that because we have so many cool things to show you today. Essentially what we'd like to talk about really is modern trade-off analyses for distributed architectures. As a matter of fact, that happens to be the subtext or subtitle of our book. But wanted to kind of share with you some things about trade-offs and how to make those and some tips. But when we talk about distributed architecture is actually really, really hard. There's a lot of questions that we suddenly get faced with. For example, should I keep the notification service as a single service or maybe break it up into separate services? That's one question.
One of the tricky things about software architecture is it's all the stuff you can't Google, because you can try to Google this question: should I use orchestration or choreography for the order processing workflow? But the stuff Google's going to tell you is not going to be useful because Google doesn't know anything about your order processing workflow. So this is another tricky question in software architecture.
Yeah. Another one actually has to do with reuse within distributed systems. This is a question that suddenly we have within distributed architectures. In other words, should authorization be implemented using a shared service or a shared library? Which one's the right choice?
What about this? Should I use a really tight contract to bind things together to make sure that I get good contract fidelity, but that forces me to do versioning and deprecation and that kind of stuff? Or should I do looser contracts and try to go versionless when communicating with a trading service? Which one of these is the right answer?
And as a matter of fact, bringing it up to a higher level, should we actually be using a distributed architecture? Or maybe a monolithic is well suited? How do we actually determine if we should maybe take the chance on something simpler at the start and move to distributed, or stay directly to distributed architecture from the start?
Good question. What about this? I've built my microservice architecture. What should the transactional boundary be within my workflows? Should I try to make the entire thing atomic so that I get good consistency across all queries that workflow? Or do I try to make it eventual consistency, which makes the workflow and error handling easier, but now I don't have consistent state?
And oh, Neal, one of my favorites, the coin toss. Should I use synchronous or asynchronous communication when communicating with a particular service? I love that one because actually, Neal, I think, in all joking aside, I think sometimes it does become a coin toss. Yes.
Ooh, some of these questions used to be easy questions, but now they've managed to become difficult over the last few years, because used to it was, oh, the relational database is the golden hammer for storing data, but now we have all these different choices: relational database or graph database or key value, cloud-based on, oh man, my brain's starting to hurt now from all these decisions.
You think that's bad, Neal? How about this choice? Should I use queues with point-to-point messaging or topics, pub/sub, to send messages? I mean, does it even matter? I mean, are there trade-offs even associated with that? As a matter of fact, out of all the things, all those questions Neal and I just described, of which we'll be talking about some, or well, I hope all of these in the session, but we don't have like, I think 4 weeks for the session. I think we only have an hour, but we're going to get to as many of these as possible. But there is an answer to every single one of these questions that you will be faced with in distributed architectures. And I think at this point in life, everybody knows the answer to these questions. It depends. And that is what makes software architecture and distributed architectures actually hard. So back about, well, how long ago was it, Neal, that we, 7 years ago, I think, we actually started writing the fundamentals of software architecture. Might have even actually been more than that, Neal. And we published this book in February of 2020. Now, in the book, The Fundamentals of Software Architecture, we actually did coin a law of software architecture, as a matter of fact. And that law of software architecture, our first law, was that everything in software architecture is a trade-off. That's what makes software architecture hard. That's why we always say it depends for any given answer or trade-off that we have. As a matter of fact, our latest book, the one Neal referred to earlier, Software Architecture, the Hard Parts, we actually address every single one of those questions and the corresponding trade-offs to really help you, I guess, guide you and help you to make the right choice between those. So what we'd like to do in this session, and we're going to save some time for Q&A, so get those questions coming, because Neal and I love questions, but we're going to talk about how to do modern trade-off analysis, and then show you a couple of pro tips. And in those pro tips, actually talk about some of these trade-offs of how do I decide to use orchestration or choreography or tight contracts versus loose contracts. So let me show you, before we dive into the nitty-gritty of those pro tips on kind of how do we do trade-off analysis, let me show you the overall flow. So everything in trade-offs and in architecture, in our opinion, really starts with those business needs and business drivers. For example, irrespective of the kind of system that we have, the biggest concern for our company, for the business, is time to market. Getting features and changes and bug fixes out to our customers as fast as possible. So what we do as architects is, of course, translate that time to market to various architecture characteristics. Some people call these non-functional quality attributes, system quality attributes. We prefer the title architecture characteristics. And as a matter of fact, this does translate into maintainability, testability, and deployability, things that the architecture must support regardless of the functionality to achieve that time to market. This lays the grounding, the foundation for all decision-making and all trade-offs in architecture. For example, any of those 9 trade-offs we talked about just a little bit ago, we're going to have a choice. Well, I can do some trade-off analysis, and really what it boils down to is performance versus maintainability. Well, okay, if I can boil it down to that, now how do I make my decision? Well, the first thing we tie it back to are, what are those architecture characteristics that are critical for this system? And we see that maintainability is in fact one of those. Then we tie it back to the business drivers and say, which of these would satisfy those business drivers in conjunction with that characteristic? And we get time to market. And that's how we make our choice. And so this kind of flow is necessary in order to do any sort of trade-off analysis within software architecture. It really does start with understanding those business drivers. So what we're going to do here is actually tag team, and Neal and I are both going to show you different tips on how to do trade-off analysis, and watch out for different traps. As a matter of fact, Neal's going to start with the first trap when actually looking at trade-off analysis.
Yep, so this is basically a partial summary of the last chapter of our book, which is chapter 15, because the first 14 chapters of our book tries to answer, so the follow-up question to it depends is always, okay, depends on what? And that, of course, is the topic of our book, Modern Trade-Off Analysis for Distributed Systems. And we spend the first 14 chapters illustrating how to do that kind of trade-off analysis, because here's a kind of a teaser. There are no answers in our book only better ways to form questions. And so we show you our applying all these trade-off techniques. But then in the chapter 15, we summarize many of these traps, and we're going to summarize a few of those for you here today. And the first of these is watch out for the out of context trap when you're analyzing trade-offs. One of your instincts as an architect is to do a deep analysis every time you bump into a problem. And here's a great example of one of those. One that we talked about earlier, that maybe one of the first ones that made you really start scratching your head. It's like, ooh, that's a nasty question. I can't decide whether to use a shared service or shared library for all the common functionality in the system. This is a common conundrum in microservices kind of architectures because, okay, well, all of my services need this functionality, but should I make that a service and make calls to it and undergo latency, or should I make a shared service and couple to it? So the way that you do this, and the way you do all trade-off analysis in modern architectures, is what we call a qualitative analysis. You put together a list of, okay, what are the pros and cons here for each one of these solutions? And you start walking through these options. So heterogeneous code is better sorted, is not served by a shared library, but better served by a shared service. Same for high code volatility is not well shared because a shared library, of course, every time we update it, we have to share it. But I can much more cleanly version changes in the shared library world. Dependency management now is harder with a shared library and much easier with a service because it's communication, not dependency. My overall change risk is less in the shared library. I don't have to worry about so much about things getting out of sync or some issues around that. What about performance? Well, performance is going to be much better in the shared library because it's in process rather than making another network call and undergoing latency. So that's better. What about fault tolerance? Well, probably better in the shared library because, again, it's in process, so I don't have to worry about circuit breakers or any of the fallacies of distributed computing or any of those headaches. So what about scalability? Again, it's in process, so scalability may win out as well. But this is the trap.
Actually,
See,
Neal,
I've pretty much convinced you, right?
Well, no, this is kind of an obvious choice. Look at our scorecard here.
Exactly, which is exactly the trap. Because you did this deep analysis, and it's like, well, hey, this is obvious. We got more green check marks on the left-hand side than we've got on the right-hand side. But here's the problem. When you look at the entire context of that situation, it's not generic. And this is the problem with trying to do generic trade-off analysis to say, in general, those things are true. But specifically here, we leverage polyglot programming and have services written in 4 different languages in our ecosystem. Performance and fault tolerance aren't big concerns for us. It's really about managing change to shared functionality. Oh. Well, when you put that in the mix, then it becomes clear that even though in a general generic face-off, you may have some better, more attractive features for the shared library, but in this context, there's a clear winner here because of constraints introduced by the other solution. That is the out of context trap. Be careful of trying to do overly generic or overly general analysis. That's one of the tricky things about software architecture is generic advice is almost always useless because architecture problems are annoyingly specific. And so you've got to make sure that you get the right context for your decision and you don't end up following some generic advice and end up hurting the value for your particular solution.
Yep. All right. And, you know, we all do scorecards and scorecards are extremely useful. It's just this is a very common trap. You know, sometimes we apply that context with scorecards in terms of weighting. In other words, we weight certain features. Well, that's good, except what you start to realize is we're actually adding low numbers to things we just really simply don't care about. So that's why we like this context application better, zeros and ones. Well, you know, another trap that a lot of folks fall into is really the fact of jumping to a conclusion during trade-off analysis. And this pro tip really is to make sure you model all the relevant business use case scenarios to extract trade-offs. Now, there's a couple of points about this relevant. Don't model use cases that are out of context or that you don't use, but make sure you do all of those use cases. Let's actually see a trade-off example using granularity. So here's an architect that says, well, I wonder if we should have a single payment service for all of the ways we can apply a payment, or a separate service for each payment type. Yet another decision and trade-off analysis we need to make in distributed architectures. And this really involves things about service granularity. So let's run through some business use case scenarios to tease out some of those trade-offs. You know, when we build the scorecards, a lot of times we have to know what those trade-offs actually are. So for example, let's do some scenarios and see if we can see what the trade-offs would be between these two. Well, let's say we do a lot of updates. Oh, I don't know, to credit card processing. Well, now we can draw that scenario or use that scenario in each of these options. For example, in the first consolidated service, well, I'd have to change the code inside that payment service as well as the shared database that it's associated with in that bounded context. But unfortunately with that, it's going to take a lot longer because I have a broader testing scope and a broader deployment scope as well. So this kind of increases deployment risk. However, if I were to split my services or split that service up into different services, one for each payment type, now when I update credit card service, I update its corresponding data if needed and the corresponding functionality. That, folks, is my testing scope. That would be my deployment scope right there. Hence, less deployment risk, better testability. And so clearly here, the separate services win. They're in green: maintainability, testability, deployability. Oh, you know what? You're right. Thank you, Mark. Let's go with the split services. But that's the trap. Because in modern trade-off analyses, what we want to do is make sure we model all our relevant business cases. For example, a lot of times what we do is continually add new payment types. Everyone comes out, a Venmo or PayPal or anything else. As a matter of fact, let's say that we want to start doing reward points. Well, what would I have to do in my consolidated service? If I wanted to add reward points, I'd have to add the code and probably modify a lot of the shared objects or classes in there as well. And I'd have to, again, modify our database. Now I'm potentially impacting other aspects of that service. Therefore, my testing scope really is and should be that entire service, as well as now deployment risk. As a matter of fact, when I deploy that service, if I don't have hot deploys, credit card, gift cards, PayPal are all non-operational during that deployment. But wait a minute. What if we split the services up? Here is what I would do, folks. I would simply just add a new service. I'm not touching or impacting credit card, PayPal, gift card at all. And so as a matter of fact, we see that what we're drawing out is, oh, that's a lot better extensibility. So my question is this: have I convinced all of you that splitting up our service really doesn't have any trade-offs? Maintainability, testability, deployability, extensibility. I mean, why wouldn't you do this? This is my justification. And therein lies the trap again. Because we do have one other scenario. And by the way, I'm going to actually add a little bit of spice to this. Do you remember our first law of software architecture? Everything in software architecture is a trade-off. Neal, would you like to tell everybody what our corollary is to that first law?
Yes, if you think you found something that isn't a trade-off in software architecture, it just means you haven't identified that trade-off yet.
Aha. Interesting clue, because all we see is the good. Keep digging. So now we have two reasons. Are there any other business scenarios that we could think of that would help us in this trade-off analysis? Why, yes, in fact, there is. Because you know what? In our company, we use multiple payment types for the payment. I could pay half of it with a gift card, a quarter. As a matter of fact, just split it evenly across all my different payment types. Oh, well, what would we do in the consolidated service? Well, I write a simple class. It's still just an entry point in that service that orchestrates all of that through code. And well, we've got a database with transactions. And so if I have to roll back, I actually do have an ACID transaction, a database transaction. But let me ask you, what would we have to do on the right-hand side if we split up our services? Oh, first of all, I'd need to add a new service, some sort of orchestrator. I would have to realign all of my endpoints and all my gateways to go to the payment orchestrator first, then to each of the one of these individual services. As a matter of fact, now I'm starting to add a bit of complexity and also some performance loss. And also now I'm dealing with distributed transactions through my bounded contexts, which means its error handling is going to be really complex. Uh-oh. So now we see the right-hand side finally has a trade-off. We've extracted it through these scenarios. Yeah, performance and data consistency are going to be horrible if I split these services up. Now that I've done my trade-off analysis, using all relevant business cases, I can now go to my business stakeholders or my product owner and say, by the way, which is more important to you, performance and data consistency, or extensibility and agility, the ability to respond quickly to change? Now I have an intelligent question to ask my stakeholders.
This really cannot be overstated, because the job of modern architects is not find silver bullets laying around, because they just don't exist. The job of modern architects is to do good objective trade-off analysis and bring exactly that kind of decision to decision makers, so that, okay, here are the objective trade-offs on either side of this decision. Neither of them are perfect, because nothing is perfect in our world, but we've done as good a job as we can of doing objective trade-off analysis. So now we can make decisions with confidence that we understand the scope of what we're talking about. Here's another common trap that you fall into in architectures, is comparing apples to oranges accidentally. And there's a great bit of advice here that comes from the technology strategy world, actually, and that is to use MECE lists. MECE is an acronym that stands for mutually exclusive but collectively exhaustive. So when you are doing comparisons for things within a category, what you're looking for are mutually exclusive things. In other words, things that don't overlap with each other, and each of them forms a complete category unto itself, or a complete part of that category with no overlaps. And the second part is, you want something that covers the entire space, so you're not leaving any parts out. So ideally, if you're trying to explore some sort of space, you want to find tools that cover the entire space but don't have a huge amount of overlap. And if they do have overlaps, you want to tease them apart so that you can really start to compare like things to one another. Now, this is fairly abstract because it's boxes inside boxes. Nothing could probably be more abstract than that. So let's look at a concrete example, exactly the kind of example that you bump into all the time in your real world. So let's say that the decision has come to you as an architect to say, okay, we need to decide between using a particular message queue versus using an enterprise service bus. Now you've fallen into the trap, because the enterprise service bus includes a message queue and a whole bunch of other stuff. So this comparison is not mutually exclusive, and it's not collectively exhaustive. So if you're going to do a comparison like this, you need to unify things. And so you either need to compare just the message bus part of the enterprise service bus, or if we're using, let's say, orchestration, messaging, and integration hub as part of the enterprise service bus, then find good candidates on the left-hand side for a separate orchestrator, separate message queue, separate integration hub. And now you've got a apples to apples comparison. Should we use these three a la carte because they have particular strengths and weaknesses, or would we rather use the consolidated solution? This is important because we're constantly being asked to make decisions about things when they are not even decisions. And it's difficult, even more difficult, to make objective decisions when you can't unify them. So using MECE lists is a good way to not only unify decisions like this, but also find, are there gaps in my analysis for some places where tools should be there, they're not, because we haven't collectively exhausted this entire category yet.
Wow. Neal, I don't know if I've ever heard the phrase, wait a minute, that's an apples and oranges comparison. Well, here's a good example, Neal. Should I use orchestration or async communication? Ooh.
Well, there you go. Perfect example. Apples to oranges. Yep.
Yeah. Boy, there's a lot of those we could talk about. You know, another tip that we do want to share with you is try to avoid over evangelizing any particular technology or solution. And this is something that's so easy to fall into the trap of, because we get excited about a particular technology or framework or platform, and we want everybody to use it because we love it. And let me show you an example of how this could lead you down a really bad path. Hey, you know what, Neal? I just realized we should have some fun and take all of these pro tips and actually turn them into anti-patterns. Trade-off anti-patterns. That would be a great idea. You know why that's fun? Is because it's always fun trying to make up the names of them. So let's show you an example, because for me personally, as Mark Richards, I always use publish and subscribe broadcast messaging using topics, because, and I'll tell you why I always use it, because it's best at supporting architectural extensibility. How do you evolve our architectures? How do you provide that extensibility? It's easy. It's using pub/sub broadcast messaging. And as a matter of fact, if you don't believe me, I am going to spend a little bit of time here convincing you that this is the best solution. Let me show you why. Let's say we have a bid producer and we're doing auctioning. So we're sending out bids. Do I hear 100 for this? Yeah, I'll do 100. And we've got 3 different kinds of services: a bid capture, a bid tracking, and analytics. Well, if you're going to use that nonsense with queues and point-to-point and stuff like that, we would have to have a queue fronting each of those services. And furthermore, to make it even more complicated, we would actually have to have different contracts for each of our services and different queues. Well, this is, quite frankly, a lot of nonsense, because let me show you why this doesn't work and why I always use pub/sub. Let's say we want to add a bid history. Well, we want to do a kind of a historical analysis of bids and see if we can do correlation between timing, or the time of month or the time of day. Seems simple, doesn't it? Well, if you happen to use this nonsense with queues and point-to-point messaging, you're in for a lot of headaches, because just putting that service in means I have to, first of all, establish a new infrastructure. I have to get a new queue, or maybe even a new broker. I also have to modify my producer. This influences another service. I now have to say to that producer that's producing all these bids, oh, by the way, can you connect to me, because you need to send me some stuff as well. And I got to figure out a contract. That's a lot of work. This is why I always use pub/sub messaging. Look at this. Simplicity comes to mind. There's just a topic, folks, or a notification service. I send an item bid, just subscribe to it. It ignores all this nonsense of this really complex infrastructure. And let me convince you further. You see the bid history? Oh, I'd like to do bid history. Fine, do it. Because you know why? Folks, there are no changes at all anywhere in my system. You see, I'm using the same topic, just subscribe to it. No changes to the producer. As a matter of fact, look at how simple the producer is. It just has one connection to a topic. Here, I'm sending out a bid. I'm decoupled. I don't know who's getting it. And also, there's just a single contract. This, folks, is why I always use publish and subscribe messaging. So,
congratulations, Mark. You have found a silver bullet in software architecture, something that always works exactly the way you want it to. That's amazing.
And you know what, Neal? I think I've just described a best practice. Yeah. So I would challenge anybody to say that this is not what you should always use. But wait, that corollary from our first law of software architecture now comes into play. You see, I'm guessing through that journey, you're sitting back and probably going, wow, he's right. You know, I'm going to start using PubSub because, yeah, that's great. Good job convincing me, Mark. Yeah, but what about security? What about data security? Because everyone has uncontrolled access to the data you're putting in a topic. As a matter of fact, this is so decoupled that the producer that's generating those events or messages has no idea how that data is going to be used. So I've got maybe some access control. Well, yeah, but what if the bid history needs additional information? What if analytics needs information that capture doesn't? Or what if tracking needs some stuff? In other words, what you've done here, Mark, is you've put a single generic contract, a universal contract that is supposed to handle all situations. I may want to fine tune this because I may not want to send data to some of these, and each one might have its own data needs. And this, by the way, gets into the whole thing about bandwidth and stamp coupling and all those things. Also, any of you who do a lot of messaging quickly realize, wait a minute, part of what we have to do in this auction system is auto scaling of services. And the way we do that is the throughput. How we measure throughput is the queue depth. So if I'm using a topic, I can't monitor a queue depth. We can't use auto scaling. Oh, yeah. That's why we encourage you not to over evangelize a situation. Because here you see, all of a sudden, we end up with a trade-off. You know, with queues, we can certainly have heterogeneous contracts. We can start securing access control to certain data. It's not just available to anybody just to, quote, subscribe to our topic. And as a matter of fact, I can't monitor that queue. I have no idea what our throughput numbers are, and I can't auto scale. Here, I can auto scale. But over here, I've got extensibility. I can easily add and remove consumers at will. So now we can ask, yeah, but which is more important to you? Data security, separate contracts, or extensibility and agility? You see, everything is a trade-off. And this is what makes this trade-off analysis so difficult. So when we try to start over-evangelizing something, just realize that everything has its own specific context. And what do you call it, Neal? I think snowflake architectures, because every one of them is entirely different.
That's the point of this, and that's why generic advice is so terrible, because no architecture looks like the architecture you have, because it's a combination of the stuff that's good and the stuff that's bad, and the stuff we like and the stuff we don't like, and the stuff we're kind of stuck with and the stuff and nobody else in the world has that kind of architecture. And that's why you can't Google it, so imagine your architecture and imagine you come up with some problem. What are the chances that someone else has exactly your architecture and has exactly the problem you run into and figured out how to solve it, and then took the time to write it up in a nice blog or Medium post for you and published it so that you could search for it? I mean, the Venn diagram for the intersection there is about to collapse into a singularity, because it just doesn't happen, which is why it's so important to get good at your own trade-off analysis. Here's another good example. And something else that Mark is talking about is that you can't say always in architecture. Generic advice is useless because software architectures are not generic. They're highly, highly specific. and you have to apply highly specific problem solving to them.
So there's two words that this particular architect used that Neal would probably stomp on their head about. Watch out for those. So if you're wondering if you're over evangelizing something, watch out for these words: never, always, best. These are indicators that, I may be starting to over evangelize something that maybe I should just step back and let's do some mature trade-off analysis on this particular situation. So yeah, those are some words to watch out for.
And you're also helping to future-proof your career, because if you evangelize something now, one of my observations a few years ago is that yesterday's best practice becomes tomorrow's anti-pattern. And if you become known as the evangelist for this thing that, through no fault of your own, becomes kind of an ugly part of your architecture, you'd rather not be associated with that. But if you've always been the objective arbiter of trade-offs, you can say, well, yeah, we identified that negative trade-off when we were doing that before, without getting caught up in evangelizing. Because the problem with evangelizing is you tend to overemphasize the good and start ignoring the bad, and that's when you get in trouble.
Exactly. So we have, I think, time for probably one more tip while you're forming your questions, because we do want to save some time before we have to go to answer some of the questions that you have. So while you're forming those questions, we've got one more tip here to share with you. And that is this: when you're doing trade-off analysis, try not to overwhelm your product owner, your sponsor, your business stakeholders with too many trade-off choices. It gets overwhelming, and a lot of those are technical in nature. And the point is, your business stakeholder is not going to be able to answer the question. So one of our tips is to try to bottom line it for that business stakeholder instead. And as a matter of fact, let me show you a quick example of that. So here's a common decision. I can't decide if I should use synchronous or async communications to kick off that credit card approval process after we accept the application from the customer. So here we have the scenario, folks, where we've got an application service, and this particular service interacts with the customer to fill out the credit application. But then we've got a large back-end process that does all the approval, accounting, and this could take anywhere from 5 minutes to 2 days. And so this is kind of more back-end. It's one of these handoff situations. We'll let you know within 1 to 2 days if your credit is approved. Well, the question is, we've got two different, and I'm going to use the term, Neal, architectural quanta here. We've got a front-end concern that's standalone and a back-end concern. So how should I communicate to that new application service that you see right here that acts as an orchestrator to be able to kick off and process this credit card application? Well, what are the trade-offs? This is that coin toss I was talking about before. So if we choose to use synchronous communications, let's say using REST, the customer waits, hits submit, sends it over to the new application service orchestrator. Orchestrator says, okay, I got it. I'm going to start the process, but I'm going to send you back 200 saying, yep, got it. Everything's cool. I'm okay. Async, what we would do is a fire and forget message to a queue. Nope, there it is. At some point, the orchestrator will pick it up, and it does after the customer's left and starts to process it. In so many of these things that we talked about so far, these are questions that you will absolutely have in a distributed architecture. So how do we tease out these particular trade-offs? Well, in the synchronous, the customer has to wait for that credit card approval process to actually guarantee it's going to get kicked off. And so I'm going to have less responsiveness there. But on the counter side, that credit card approval process is guaranteed to start while the customer is hanging on the line there. I mean, I've got that make that spinning thing go away problem here. But the problem is, if that orchestrator, that backend system is not available or is non-responsive, I'm going to reject that application, and the customer is going to have to try all over again. Well, what if it's async? The customer doesn't have to wait. Here's the credit card application. Thank you. And that is a couple of milliseconds. As a matter of fact, probably around 17. However, then the problem is, though, that may be a stuck message. The message may have gotten lost. Gee, nothing got kicked off. Sorry, we lost your credit card application. You can re-enter it, please. But on the good side, though, we have no dependencies on the back-end system or that orchestrator from being available. Can you imagine, folks, sitting with a business stakeholder, going back and forth, just as I did with you? It seems a little overwhelming, doesn't it? That's what we're talking about with this tip, about having too many trade-offs to say, well, do you want to wait for it, but it's guaranteed, but also they've got availability problems, but responsiveness. So the tip here is to simplify and bottom line that. In other words, which is more important to you as the product owner? A guarantee that the credit card approval process will always be started when an application is submitted? And I mean guaranteed because that's synchronous. Or do you want this to be really fast and always available? That's the choice. Notice how I really simplified it to a business concern as opposed to all this technical availability and stuff. That's really that tip. So our bottom line in this really is that essentially everything in software architecture is a trade-off. And this trade-off analysis is hard. We showed a couple of tips here to really help guide you in terms of some of the anti-patterns and traps that we do face when we may make the wrong choice and we're not sure whether we're making the right choice or not. All right, so that is our kind of, I will say, lecture part, but we'd love to get into any sort of discussions or questions or scenarios that you might have questions or concerns about regarding trade-off analysis.
Indeed, I think we stunned everybody into silence. We're not getting any questions yet. So.
Well, I'm at least glad he put his photo back up, so at least we can see his response.
Oh, there you go. Yes.
So let's talk about this. Is a great question. Which is more important? And I was going to ask the two of you, in my experience, talking to business users, even if I simplified it, for example, in your last case there, and I said, which do you want? Do you want the guaranteed or do you want the fast performance? They will look at me and say, of course I want both. Right. I have never had a business user, once given a constraint, say to me, well, I'll live with something, How do you?
If a client comes to you and says, well, this software system has to cure cancer. Well, it'd be great if it could, but I don't know how to make it do that. So it's the exact same thing. You're talking about engineering constraints here. So you have to pull it back to engineering. I mean, the business may want a lot of stuff, but you can't deliver things that they want if it's not feasibly impossible, or if it's not feasibly possible. One of the things that the business always wants is that everything should act transactionally at all times.
Right.
But the real world doesn't act transactionally at all times. One of my former colleagues, Gregor Hope, famously made the observation that Starbucks does not do a two-phase commit. Okay. But when you go to Starbucks, they're doing eventual consistency because it's too inefficient to do transactions in the real world. And so it's the same thing, that there are abstract ideas that sound terrific, but when the rubber meets the real world, you have to start making compromises. And I agree that one of the things that Mark and I try to do is never show people too long a list, because they always want all of those things. So if you'll notice, we're trying to boil things down to the really crunchy center to try to get them to understand that it really is an either or kind of a scenario in many cases.
That's a great point. It is. And again, we as architects often have to deal with people who really want their cake and they want to eat it too, and they don't want to gain weight, the whole bit, right? I appreciate that. Now, let's talk about when these kinds of what if questions really have to deal with the technology, the engineering communities that have potentially, let's call it engineering biases. So, you've got the one group that is all about thou shalt use the enterprise service bus. There's the other software development team that's saying, we don't know anything about enterprise service bus. We think it's a lot of overhead. We think we can implement this in half the time, doing it through queuing on our own, So when you start dealing with, let's say, just the internal IT type stakeholders, and you start talking to maybe the ops side, and they say, we don't care what you do as long as we can monitor it, and you better make sure we can monitor it end to end. So let's go back to that monolith thing that we liked so much before.
Yeah. Well, one of the things, Roman, let me just say really quick here. One of the things we battle over a lot in trade-off analysis is unfortunately navigating the horribleness of opinion and preference and passion. And you're right. There's, as a matter of fact, Neal, I'm hoping you're going to talk about the caveman piece, because that also plays into this from experience. But yeah, that's one of the challenges that we face in trying to do trade-off analysis, is overcoming those opinions and being much more open and subjective about other ideas. Neal, you were going to say
that's why I think that's why it's important not to be an evangelist, because when you're an evangelist, you immediately put yourself into a confrontational situation. Oh, I'm the ESB guy. No, I'm the message queue guy. And that's not, you don't want to be there, because now you're, artificially creating silos between each other. That's why I try to instill in all the burgeoning architects at ThoughtWorks, you are the objective arbiter of trade-offs. And when one contingent comes and says ESB all the way, and another contingent says, no, it's got to be loosely coupled queues, it's like, okay, let's get all these people together. Let's do an actual trade-off analysis. And we're not going to let you bias it to say that this is, that much better. And let's see if we can come to an objective agreement about, when it's proper to use one thing versus the other, because it may not be all or nothing. It may be a case by case, but, getting everybody to an objective place. There's too much enthusiasm in evangelism in our world, and if we can cool that off and get it back to objective trade-offs, then I think we do a better service to our organization.
Okay. Then the last question was, have you guys thought about or seen anyone try to implement some kind of, let's call it a weighting or algorithmic process around trying to take all these trade-offs, put weights on them, and then get a score?
Here's the problem with doing that. but here's the problem with doing that. Nothing in software architecture is generic. So one organization might put a weight on synchronous versus asynchronous that another organization would put a completely different weight on. One organization might care a lot about security. So it's just too hard to.
I get that. But if you were to create the template that says you guys decide what your weights should be under performance, under whatever, and then this will give you a score at the end of the day. That kind of.
Oh, absolutely. We are big favors of that kind of analysis techniques within an organization. So we are big, we build matrices so we can do trade-offs and delineate things. Yeah, that's a good way to do it. And weighting is a good way to do it, because weighting gets away from the problem I was just about to go into a rant about before you stop me, which is what the perspective of this organization is on this aspect of architecture. That, at the end of the day, all you really care about is what your organization benefits from, not from what the industry benefits from, because the industry doesn't have your architecture, you have your architecture. So that's a very good way, in fact, of coming up with a more and more refined trade-off analysis, if you can pick weights and then refine those weights over time that really reflect value in your organization. It's a great way to.
And it is a good practice. One of the challenges, though, Roman, in that I've experienced and seen firsthand, is the subjectiveness that people place on various weights, because essentially what you're doing is almost a prioritization of which is more important, scalability or performance. And it's like, well, both. Well, some people may say scalability, some people may say performance. And what I found with the weighting game, I like that, weighting game, is in fact it's a slow process because you do have to gain consensus in terms of what those weights are, as opposed to what I was referring to with that binary kind of choice, a 0 or a 1. And that way it's like performance doesn't matter to us. And so the weighting is a 0, but these things are. And that really then does tease out to see if a particular solution is in fact viable for us. Yeah.
And one of the things so I'll give the last question from the audience. One of the things you guys really didn't talk very much about, I think tangentially talked about it, was cost. So the question goes around, do you have any tips on balancing the cost dimension whilst making these kinds of trade-off decisions? Cost tends to be, the popular senior stakeholder decision maker criteria.
Well, that's always one of the forces in play in an organization, because there's a famous story actually told in Dreaming in Code of the project that had infinite budget, infinite time, and infinite resources and still failed. So it's worth reading just to hear that even if you remove costs, you can still fail miserably on a project. But yeah, that's always a concern. But the other thing that's worth mentioning about cost is that really gets to the crunchy center of the way the organization views software. Because if all of your decisions are dominated by cost, that means you view software as overhead, meaning you're trying to minimize cost, versus viewing software strategically, where it's really a strategic advantage, where you may be a little less conscious of cost and more conscious of how is this being a competitive advantage for me. So too much emphasis on cost, I think, is a bit of a warning sign that we're an organization that views software as overhead, and that drives a lot of the decision process.
That's an excellent point, Neal. So let me do this. Just maybe if Mark, you can put up the book again.
Oh, yes. Okay.
Or is it out already?
It is. As a matter of fact, let me show that again here. And our book, which we published in November of 2021. So yeah, that's been out for about 3 months now. Software Architecture, the Hard Parts.
Okay. Thank you so much, gentlemen. I really appreciate your talk and a lot of great points today.
Wonderful.
Thanks for
having us. And again, apologize for my my video angst there. It's like, but I think it still worked out fine. So thank you.
Okay.
Great. Thanks, everyone.
Bye-bye.
Bye-bye.